Okay, so hello everyone. Today in this presentation, my team will be explaining about the problem statement we chose, which is the fake fingerprint detection. The objective is to explain the significance of this problem, the customer perspective, and thinking for a solution. So let's get started. So first of all, what are fingerprint sensors and why do we use them? Well, fingerprint sensors are used for biometric identification by identifying the fingerprint of a person, which is unique for each human. Fingerprint biometrics are used pretty much everywhere, ranging from offices to college mess. These devices are better compared to using a password or PIN because we don't need to remember anything for the identification to worry if we forgotten the password we entered. No sort of memory is required for fingerprints. Also, if we use passwords or patterns or PIN, someone could see us entering it, remember it, and access our resources. Such is not the case with fingerprints, we assume. But that is not entirely correct. Consisting the existing model, there are two major flaws associated with fingerprint sensors. First one is the problem of spoofing. You might have seen this happen in movies and probably in real life as well. An intruder can make a mold of the fingerprint and access a system. Secondly, the fingerprint of the user could be simply used while they are not conscious or aware. For example, if the person is sleeping, the intruder could use their fingerprint to open the phone by simply knowing which finger they use and placing it onto the phone. The system wouldn't know that someone else is accessing the phone. As a result, we can say that fingerprints are not completely secure. Consider these examples. If a person touches a surface, the fingerprint of the person may easily be extracted. This is one reason fingerprints have been easily planted in the scenes of a crime. People with grievances against others can decide to extract their fingerprints and plant them in the scenes of crime. This is a major flaw of fingerprint identification that has been noticed for years. Another thing is with the problem of recreation by using the biometric attributes of the user. One example is that of an ethical hacker called Jan Chrysler, who was able to hack into the biometric identification of the iPhone and access it effortlessly. He was able to recreate the fingerprint of Ursula von der Leyen, the then German Minister of Defense. All he had to do was to capture the fingerprint of the German minister while she was on TV. Another example is the Chaos Computer Club. The team members were able to beat the fingerprint feature of several iPhones by creating molds of fingers. In addition, there has been research done towards using fake fingerprints to imitate real ones in biometric systems. Researchers have used a neural network to generate artificial fingerprints that work as a master key for biometric identification systems and prove fake fingerprints can be created. This was a paper presented at a security conference in Los Angeles. The artificially generated fingerprints, dubbed Deep Master Prints by the researchers from New York University, were able to imitate more than 1 in 5 fingerprints in a biometric system that has an error rate of only 1 in 1,000, making it perfect for fingerprint imitation. The researchers, led by New York University's Philip Bontrager, said that this result will have a broad variety of applications in fingerprint security. Demonstrating flaws in existing authentication systems is as important as security research for developing more secure replacements in the future. The developers took advantages of two weaknesses associated with fingerprint sensors. The first is that most fingerprint readers do not read the entire finger at once, instead, imaging whichever part of the finger touches the scanner. Additionally, such systems do not blend all the partial images to compare the full finger against a full record. They only compare the partial scan against the partial records. That means that an attacker must match just one of tens or hundreds of saved partial fingerprint to be granted access. The second is that some features of fingerprint are more common than others, meaning a fake fingerprint may contain a lot of common features that would match with other fingerprints than pure chance would suggest. Using these observations, the researchers used a machine learning technique called a generative adversarial network to artificially create new fingerprints that match as many partial fingerprints as possible. This neural network not only facilitated in creating multiple fingerprint images, but also created fake models which look convincingly like a real one to a naked human eye, which is an improvement on a previous technique which created jagged, right-angle fingerprints that would fool a scanner but not a visual inspection. This technique of generation was compared to that of dictionary attack against passwords, where a hacker runs a pre-generated list of common passwords against a security system. The probability of achieving a breakthrough in detection into any specific account may be meager, but when used against accounts at a large scale, generate enough successes to be worth the effort. Now that we understood the drawbacks and the impact of the problem, let's get to the next part of this presentation. So, who exactly is a customer? Well, the range is pretty large. Anyone who is involved in using fingerprints to gain access to places or personal things are the customers. Any one of these users have a fair risk of getting their fingerprints stolen, duplicated, or recreated. The customers could be smartphone users who use fingerprint to unlock their phones, or people using fingerprint encrypted safe to protect their money or valuable resources, or someone who uses fingerprint for authorization. One known example is a biometric in the college mess. Now let's get an idea about the customer perspective of this problem. Having a reliable and secure way of authorization or identification by a device or system is essential and desirable by everyone. So a customer would like to have a fingerprint system that is immune to any sort of duplicated entries that mimic the fingerprint of the user in one form or another. But for the currently used fingerprint identification system, there is no guarantee of that. Hence, our current solution is to make a device that can tell whether it's really that user trying to access the data or resources for someone else. But how can this be done? Well, one possible solution can be to detect the depth of the finger. This can be done by processing or interpreting the light or heavy touch and swipe of the user, through which we can possibly find whether it's an actual finger or just a thin paper containing the fingerprint sample. But what if the user is unconscious? For that case, we can consider the fact that when the user is awake, they would keep the phone in the hand and press the sensor with the required finger. But if the intruder does it with the fingerprint of the user, only the finger would be placed on the phone. not the entire hand. Maybe we can use this observation to build a solution. And that's the end of the presentation. I hope that you like it. Thanks for listening to this presentation. Thank you.